Good afternoon. I'm Mateusz Rydlewski, and together with 3 units of Gdańsk University, represented here by Dr. Marcin Budzyński, University of Nottingham, represented by Dr. Raza Remenai-Prescott, and Wrocław University of Science and Technology, represented by Agnieszka Tubis and myself, I'd like to present to you the paper, or more the effects of our work on the safety assessment of tram loops on the example of Gdańsk. The basic information about the literature review which we've done in terms of tram system safety are based on 3 basic segments in risk management. That's risk management, accident, and the human factor. Here we are presenting a small diagram on which we are classifying the various elements in terms of the 2 main factors, that's accidents and human factor. The largest number of articles of reports related to tram systems we can find with regards to accidents on tram stops. There is a certain research gap that was identified, which is the lack of similar research in the area of tram loops. Therefore, the area of tram loops is what we focused on. Now, staying still in the area of tram loops, I'd like to give you a brief overview of the types of tram loops. There are very many types depending on the city. These may be characterized by a variety of features. I would like to present the 5 main types of tram loops. In the diagrams, you have 7 drawings. They're all taken from Wrocław. So the distinction can be depending on the type of ending of the line. It can be blind track with a crossing to provide double directional traffic, like example 7, or a full loop, like on all the other ones. Another classification is the way of changing the direction in case of standard loops. Here, traffic is usually counterclockwise, and the stops are located on the outside of the track. In case of a loop where the traffic is clockwise and stops are inside, it's number 2. That one is located in Wrocław. Another 3 elements for classification pertain to the organization of traffic on the loops. Now, loops can be indirect, like number 4 and number 5, where some of the tram line can end, the rest of the cars could go further, bypassing the loop altogether. All these could be ending loops like all the other ones, 1, 2, 3, 6, and 7, where this is where the track ends. In case of an indirect loop, this is factor number D, we can see the possibility of traveling onto the loop or traveling outside the loop. The joint operation is possible on loop number 4. And the last division is, this is again about indirect loops. It's possible to access them from one side, like loop number 5, or they can be accessed from both sides. That's loop 4. Further, I'd like to talk about the safety ratio which we've developed. We call it TLSI. It's Tram Loop Safety Index. And this consists of the assessment of the various criteria, and there are 5 of them. I'll give them the criteria in greater detail a little later. The ratio is actually arithmetic mean of the 5 criteria. And here they are. 5 safety criteria. The surface at the tram loop, landing surface, infrastructure at the tram stops, vehicle visibility, traffic organization, and the condition of the track itself. In the area of each of these criteria, we have standards that define the perfect loop for each of these criteria. Because we have limited time, I cannot discuss them in detail, but you can find more in the article. The scale of assessment, you can see here the point and percentage scale. Next, I will tell you step by step how you can arrive at the result based on our proposed index. The point value depends on how well the criterion is met. Here's the 5 steps. Step 1 is an audit. As a result of the audit, we receive a complete questionnaire and the most important information about the loop. Stage 2 is the assessment of compliance with the standard. What we actually do at this stage, we take the observation and the questionnaire and compare it with the standards, based on which we receive a percentage value for meeting each of the criteria. Then the value is translated into a point value. Based on the point value, we can calculate the TLSI indicator, the safety index. And for an index calculated in that way, we are then able to give priorities and recommendations for a given loop. Thanks to those recommendations, given certain priorities for the necessary safety measures, we can, at the end of the day, improve the level of safety of the users of the given loop. As I said earlier about recommendations. So we also proposed 6-level recommendation system depending on the point value, on the final score. So the point value of the actual safety index. At the first level, score is 1 or 2. The assessment is that tram loop is very dangerous for user, and the recommended action is to disconnect the loop until remedial actions are taken, and the date for the next audit immediately after repair. Next level is 2 to 3 points. Here the loop is assessed as dangerous for users. Constant supervision of safety is necessary and immediate remedial action is needed. And again, the next audit is immediately after work has been carried out. Third level is 3 to 3.5 points. This is a tram loop with very significant and numerous elements that reduce user safety. We recommend actions to be taken within 6 months, and the audit would be carried out after the measures have been implemented. Next level, level 4, the score of 3.5 to 4, that the tram loop is assessed as having significant and numerous elements that reduce user safety. And it is also here that we recommend actions, but there is more time to do them. The time scale is, timeline is 2 years, and depending on how soon after the audit remedial work is done, we recommend the audit to be done immediately prior and immediately after the remedial work is done. Next level, score of 4 to 4.5. Here, tram loop has single individual elements that reduce user safety, and we recommend possible ad hoc remedial actions and an audit once a year. The top level, 4.5 to 5 points. This is a model loop in terms of safety. We don't recommend any corrective action because the index was so high, and the audit is recommended after 2 years. Now, we've made an attempt to verify the proposed methodology by looking at the tram loops located in the city of Gdańsk. And we have a table here with basic information about 12 loops in the city of Gdańsk. We have information about the construction, reconstruction, year of build, renovation, the number of platforms for passengers embarking and disembarking, the number of lines that end the route on that given loop, and basic information about the loop's characteristics on the basis of the individual division and the relation of the loop to the tram line, and also the ability to provide service in the area of the loop to either bus transport or to connect to bicycle infrastructure. For quite a large number of people from Gdańsk here, I'm sure the map on the left is very familiar. This is the tram system in Gdańsk with the location of the 12 loops. On the right-hand side, you can see the photographs, two photographs of two loops. It's loop number 1 and loop number 12. The loop number 1 is Brentowo. This is actually the end track where trams end their route, but they can turn back switching tracks. And number 12 is Zaspa loop, where trams turn around in the traditional way. The audits carried out on each of the loops yielded the following results for the various 5 criteria. That's landing surface infrastructure, traffic organization, visibility, and the condition of the tram track. The lowest average, 3.4, was the collective index for traffic organization. Landing surface was the most highly evaluated at the level of 4.6 for all 12 loops. If we look at the last column, which is the TLSI for the various loops, the lowest value was achieved by Oliva. And now a few words about the loop in Oliva. You can see some of the photographs. The photographs were taken during the audit, and some of the elements that were noted in the loop during the audit is the fact that no pedestrian paths were set out. Partially there is no fencing. There are different levels of the platforms, and there's insufficient lighting. It's something that was talked about so widely during this conference. In terms of visibility, there's also an area where we could indicate elements of infrastructure and greenery that actually pose an obstacle to visibility. Also, we could note the low technical condition of the track. Moving on to the conclusions. As I said in the beginning, the literature overview indicates that there is a research gap in terms of tram loops. The proposed method for assessing the safety of tram loops provides the possibility to carry out a multi-criteria analysis that could be used for reporting, monitoring, but also to make recommendations about which elements need to be improved or repaired on the various loops. In the course of the research, we actually made recommendations for each of the loops in Gdańsk. As I said earlier, the lowest value was the organization of traffic on the loop. The value was 3.4 overall for Gdańsk. It may, but does not have to indicate that this is an area in which one should focus on in other areas of the tram system in the city of Gdańsk. I'd like to thank you very much for your attention. Thank you very much for the opportunity to take part in your conference. Thank you and goodbye.